Hi there, my name is Oliver MacDonald, and I'm one of the co-founders of QTex AI. And today I'm going to be showing you guys a brief introduction to the QTex system and how it can help you design electronics faster. So let's jump on in here. Now, this is a very simple conversational system that is meant to help electronics engineers or those getting into electronics find the parts they need, understand how they work, how they interact with other components, and ultimately how to integrate them into your existing or brand new systems. So let's get started with something very simple. There is a part I've seen as we've been building out our database that seems interesting. It's called the SGP40. So what I can do is just say, tell me more about the SGP40 and give me its pinout as well as footprint and supporting components. And we'll send that off. Now, you might not always have a part that you know off the top of your head, so you can also go into the system and ask for something more generalized, which we'll do here in a moment. And as we wait, you'll notice that the system does actually give printouts for the information that we want so that we can see what it's thinking, how it's going through the process, and make sure you have as much transparency as possible into the system. So there we go. We've got the information from this. It's this digital gas sensor for indoor air quality monitoring. We get some just general key features, stuff you'd see typically at the top of that data sheet, some of the big stuff you'd want to initially look at. But then from there, we also have this great pinout explaining the functions of all the pins off the bat. We've got the pin dimension, the package dimensions from there with pad sizes, signal pads, pitch, bunch of that information you need as you start thinking about, is this something that can fit on your board or is this the size you would like? And then that lists the supporting components with their purpose. So we can see we need a resistor, just to decouple the voltage, pretty common, same for our capacitors, and then our pull-up resistors for the I2C communication. So all the information that you could go find in the data sheet, but it's going to take you a lot longer to find and compile than just having it here for you in a matter of seconds. But now that's not where the system stops. From here, let's say I want to connect this to some sort of low power microcontroller so this can run just in a house and turn on the LED if things go high. So let's just ask that exactly. Now I want a low powered MCU that can communicate with this sensor and turn a light on when, let's just say, the VOCs are too high. And then from there, what we can also specify is ideally this can run on a coin cell battery for months. And I'm going to quickly double check the current consumption, just 34 microamps at idle and 2.6 milliamps during operation. So we should be able to say this for a year. And we'll see what it comes up with. Okay, perfect. And with that, we now have two different options for this. So we've got an STM chip, which I've worked in the past. I know they always have some pretty good options for low power. And we've got some of the key things we want to know off the bat. We've got the standby current, and we have the run current, which is incredibly low for us. It's got the I2C support we need. It's got GPIO that will work great for the LEDs, into typical microcontroller voltage with a very fast wake up time. And we've got that memory out there as well. With this, you can see it also can go through and do some math for you. So with most of the time standby at barely 0.3 microamps, takes every 10 seconds to read, takes about 100 milliseconds at 1 milliamp. Occasionally when VOC is high for a brief period, so this would show a bit of a flashing period. Then the estimated runtime, would work for this. And we've got another alternative, this PIC, which at the same time is also possible for this. It's got lower standby current than the STM chip, so it is also a great alternative. We're looking at 50 nanoamps when it comes to sleep mode and only 43 microamps from there. And then from there, we also get this great architecture for the system, which this is a pretty common or pretty simple architecture. It's power to your controller, which then reads the device over I2C and the GPIO. So it's very simple to see how this might work, and it brings out some of those design considerations, which is great for us. And then from there, we could really keep digging in. We can go through and ask for a pinout to show all the connections. Give me a pinout for all of the connections. My circuit. And then from there, it's just a matter of really, from this information, actually choosing which parts we want to choose to work with. So we know the SGP40, that first one that I already had, is a great chip. So while the chat works, I'm going to look up that component, and I'm just going to take the first component off the top there and add that to my data sheet. And we can actually go in and ask about what the different variants are of these different parts as needed. And then while we wait for the pinout, we can do the same for the STM chip as well. And ultimately, you can ask for this as well through the chat. I'm just running it through the sidebar so that we can do both in parallel. And again, we've got different types of variants here. We're just going to take the top one off the bat. But if you want to dig more into the variants, that's something you can ask the system. And then from there, we build the bill of materials for you within the actual system. So you can find that part, have a direct link to Mouser or DigiKey, whoever has available at that time to find it, see what's available, pricing, all in a single place. And with that, that is the bulk of our system. So here, as it starts, put out the pinout of how everything would connect to the system. That's really the starting point for how to start using the QTex system. And from there, you can keep doing more, build bigger systems, be able to get really into the weeds for some of those more complex components, all from a single interface, so that you just have to work from one platform, as well as your EDA tool, and you're good to start designing. So thank you guys for watching this short introduction. If you have any questions at all, please feel free to reach out to our team. We're always happy to help, and we're looking forward to helping engineers build better products faster.